Good evening, children. Today we are going to discuss some important areas of this mole concept, some important numericals of mole concept. Okay, so the first concept is here. How many years it would take to spend Avogadro number of rupees at the rate of 1 million rupees in 1 second time. In 1 second, 1 million rupees we are spending, suppose. Then Avogadro number of rupees if we have, it will take how many years to spend that many rupees. Avogadro number means how much actually? 6.023 into 10 power 23. So suppose these many rupees you have. Okay. And you are spending how many millions in 1 second? 1 million. 1 million is nothing but 10 power 6. So 10 power 6 rupees. 10 power 6 rupees means what? 1 million rupees. You are spending in how much time? In 1 second. What is given here? 1 million rupees in 1 second you are spending, suppose. Then these many rupees if you have, I have got a number of rupees we are having. How much time it will take? We have so first we'll convert what now here? 10 power 6 means 1 million. 10 power 6 is equal to what? 1 million. So 1 million rupees we are spending in how much time? 1 second. Then I have got a number of rupees will be spent in how many seconds? So how to get now here cross multiplication? So how to do here? I have got a number into 1 by 10 power 6. Okay. So I have got a number is this one. 10 power 23 divided by here into 1. So into 1 divided by 10 power 6. 10 power 6 is 1 million here. So these many seconds it will take. These many seconds it will take to spend what? I have got a number of rupees. Okay, now here, what is asked here? The time in years they asked here. Years they asked. We got in seconds now. This many seconds it will take. But here they asked in years. So how to calculate now here? 1 year means how many days? 365 days. So 365 days into in each day how many hours will be there? 24 hours will be there. And in every hour, how many seconds are there? 60 minutes are there. In every 1 hour, 60 minutes are there. Again, in every minute, 60 seconds are there. So these many seconds will be in 1 year. These many seconds in 1 year. So it is equal to 1 year time. So these many seconds is equal to 1 year. Then we got what now? These many seconds will be equal to how many years we have. Getting concept? So these many seconds will be equal to 1 year. Then 6 into 023 into 10 power 23 by 10 power 6 will take how many years? So these many seconds will take how many years? That is what they ask you. Is the clear concept of this? Not clear. Now, rate of spending. Rate of spending. So rate of spending is what now here? Rate of spending is 1 million per 1 second. Right? 1 million per 1 second. So 1 million rupees in 1 second time is given. And total time in seconds, how much now? I have got a number by 1 million. Is equal to total number of seconds available. And now here, now this is equal to what now? If you take 10 power 6 up, it will be 10 power minus 6 into 10 power 23. That is 10 power 17. So this 10 power 17 seconds we have to convert into years. We have to convert into years. Now then what we do? These many seconds by, so here 60 into 60, 60 minutes into 60 seconds. That is 600, 24 hours, 365 days. So this is total number of years in 1 year. Then we get what? 19.098 into 10 power 9 years. So these many years will be taken. Okay, these may 10 power 9, 19 into 10 power 9 years will be taken to spend one Avogadro number of rupees if we have. So which option is right now here in this? Option C is right. The concept there? So about what now here? Avogadro number of concept. Avogadro number concept. Avogadro number of rupees actually. The next, one more important area what we are doing is that Loschmidt number. What is it? LOSCH, Losch, MIDH. So Loschmidt number is nothing but number of molecules in 1 centimeter cube. Otherwise, 1 ml. In 1 ml gas, in 1 ml of the gas, H2P, how many molecules are there? That is called what here? Loschmidt number. So number of molecules in 1 centimeter cube or 1 cubic centimeter or 1 ml. Or we say what simply 1 cc. Cc means cubic centimeter. So 1 centimeter cube or 1 ml or 1 cc will contain how many molecules? Loschmidt number of molecules. That number is this number. So Loschmidt number is equal to what now? Avogadro number by 22,400 ml. So Avogadro number by 22,400 ml is equal to this. This is what now 2.68 into 10 power 18 molecules per ml. In 1 ml gas, how many molecules will be present? 2.68 into 10 power 18 molecules. So this number is called what now here? Loschmidt number. Is that clear? So we know that 1 mole gas equals to what now at STP? STP, 1 mole gas is equal to 22,400 milliliters, right? So this volume contains how many molecules now? 6.023 into 10 power 23 molecules. So these many molecules will be present in what now? Present in 22,400 ml. Then 1 ml. These many ml equals to these many molecules. Then 1 ml is equal to how many molecules? Will be equal to what now here? Loschmidt number. So this number is what now here? Loschmidt number. Right? So I have got a number 1 into I have got a number by 22,400 will be equal to what now? 2.68 into 10 power 18 molecules per ml. Consistent. Next, and here the term mole was introduced by which scientist? Ostwald. In which year? 1896. In 1896, Ostwald has introduced what the word mole. Okay, and this is the Latin word. Mole is the Latin word, and mole means okay, heap or pile. HEAP, heap or PILE, pile. So when we take many books, one book will be piled upon the other. Many books will be piled upon one another. That is what piling. Okay, heap or pile means one mole. So a mole, we also say MOL mole, MOL mole or MOL mole. A mole is defined as what? The number of atoms present in 12 grams of carbon 12 isotope. In carbon 12 grams of substance, how many atoms are present? Is called one mole. Is that clear? And this number is what now? 6.023 into 10 power 23 is what here Avogadro number. So Avogadro number of particles will be present in 1 mole. Okay. Next, one more thing is that atomicity. So what do you mean by atomicity? Tell me first. The atomicity means number of atoms. Atomicity means what? Number of atoms in one molecule. Atomicity equals to number of atoms in a molecule. In a single molecule, how many atoms are present? It's called atom. Suppose CO2 atomicity how much? 3. H2O atomicity how much? 3. Carbon monoxide atomicity how much? 2. So now here atomicity can be ascertained, can be given with the values of ratios of two specific heats of gases. So Cp is one specific heat at constant pressure. Cv is specific heat at constant volume. Cp and Cv are what? Specific heats. Specific heats of what gases at constant pressure Cp, at constant volume Cv. This ratio Cp by Cv is called gamma here. Gamma is equal to what? Cp by Cv. And this is what now here Poisson ratio. What is this called? Poisson ratio. Scientist name Poisson. So Poisson's ratio is what? Gamma. Gamma is equal to what? Specific heat at constant pressure divided by specific heat constant volume at constant volume. So this ratio will give idea about atomicity. What is atomicity of the gas molecule? We can understand. So atomicity can be ascertained with the values of ratios of Cp and Cv. So if Cp and Cv, Cp-Cv ratio is 1.6 suppose, then monoatomic. So what is atomicity here? 1. Atomicity will be 1. And if Cp by Cv ratio of a gas is 1.4 suppose, then that is diatomic gas molecule. Diatomic means what? What is atomicity? 2 here. Atomicity 2 for this gas. If Cp by Cv ratio is 1.4. If Cp by Cv ratio is 1.3, 1.33, that will be polyatomic. Means atomicity may be more than 2. Atomicity will be greater than 2. So polyatomic means what? No, actually it is 3. It will be 3. Atomicity 3 will be there. 3 or more. Atomicity will be 3 or more will be there. If Cp by Cv ratio is 1.33. If Cp by Cv ratio is 1.4, atomicity 2. If Cp by Cv is 1.66, atomicity 1. Now, what is the relation between Cp and Cv value and atomicity? If 1.6 is more, 1.4 is more, 1.3 is more here. 1.6 is greater value. If Cp by Cv ratio is greater, atomicity is lesser. So atomicity is inversely proportional to what now? Cp by Cv ratio. Cp by Cv ratio is called what now? The specific heat ratio. The Cp means what I told you? Specific heat of gas at constant pressure and specific heat of gas at constant volume. This ratio. So this ratio value and atomicity both are inversely proportional to each other. So this concept also everyone should understand. Okay. And here, 1 mole of BaCl. BaCl is what now? Barium chloride. So barium chloride is what? Ionic solid. Ionic solid. In ionic solids, molecule will be there or formula unit will be there. In any ionic solid, there will be formula unit. So one formula unit of barium chloride means one number of Ba plus 2 ion, and here one will be what? Ba plus 2, and there will be 2 Cl minus. So 2 Cl minus ion and one barium plus 2 ion. These two means these totally 3 ions. One barium ion, 2 chloride ion. These 3 together will form one formula unit. So one formula unit of barium chloride is equal to 1 barium ion and 2 chlorine ions, 2 chloride ions. Here. Now 1 mole means how many molecules will be there generally? 6.023 into 10 power 23 BaCl to formula units. Units meaning what? Formula units. So these many formula units will be present in 1 mole. Okay. That molecular mass how much now? 208.2 grams. It is gram molecular weight of BaCl. What is here? GMW means gram molecular weight. So gram molecular weight of barium chloride, right? Now, molecular mass or formula mass, anyone we can say. Molecular mass we can say, otherwise, formula mass of barium chloride is equal to 6.023 into 10 power 23 barium plus 2 ions will be there in this, and double the Avogadro number of Cl minus Cl. Suppose here 1 mole is equal to how many formula units? Avogadro number of formula units. In every formula unit, how many barium there? Ba plus 2, how many 1? And every formula unit, in every one formula unit, how many Cl minus there? 2 there. That's why we are taking what now here? Avogadro number of barium plus 2 ions and twice the Avogadro number, 2 into Avogadro number, 2 into Avogadro number of Cl minus will be present. Now 137.2 is what? Atomic weight of barium. It is what now? 137 is what? Atomic weight of barium plus 2. Atomic weight of barium plus 2, how much? 137. And for each chlorine, how much now? 35.5, you know. So 2 into 35.5. So 2 into 35.5, 71. And 1 barium is equal to 137 atomic weight. Atomic weight of Cl, how much? 35.5. Is that clear? So therefore, we get 208.2 grams. Is what now? Gram formula unit mass. What do you say? Gram formula unit mass of barium chloride is 208.2 grams. So 1 mole of a substance will have mass equal to 1 formula mass. This is nothing but formula mass. Gram formula mass. What do you say? 208 grams is what now? Gram formula mass of barium chloride of that substance expressed in grams. Now if we say only 208 AMU, that will be for single BaCl. So if you say 208.2 AMU, it is equal to what? 1 barium chloride unit. For 1 barium chloride unit, what will be mass here? 208.2 AMU. AMU means what? Atomic mass unit. Very small mass. But if you write 208.2 grams, 208.2 grams, if you write suppose, what does it mean here? It is gram formula mass. Gram formula mass of what? Gram formula mass of what? Barium chloride. Gram formula mass of barium chloride is what now? 208.2 grams. Now it is equal to what now? This is equal to mass of how many? Mass of Avogadro number of units. Mass of what? Avogadro number of barium chloride unit. So mass of Avogadro number of barium units equals to 208.2 grams. But 208.2 AMU is what now? A single BaCl2 formula unit. Is the difference clear between 208 grams and 208 AMU? AMU means for single particle. Grams means Avogadro number of particles. Means 1 mole particle. Up to this clear now? Yeah, next one more thing what happening is that this 22.4 liters is called what here? It is called what? It is known as gram molar volume. What is gram molar volume? At STP. STP, what is gram molar volume? It is 22.4 liters. Sometimes it will be given like this. Suppose if you take 1 atm pressure, 1 atm pressure is slightly more than 1 bar pressure. It is greater slightly. 1 atm pressure is slightly more than what? 1 bar pressure. That point you have to remember. So whenever pressure is greater, volume will be lesser now. When pressure is greater, volume is lesser. So here it is greater pressure. I'm telling now 1 atm is slightly more pressure. Now at 1 atm, the gram molar volume is equal to 22.4 liters. 22.4 liters gram molar volume. But if you take lower pressure, that is 1 bar pressure, the gram molar volume is equal to 22.7 liters. Okay, slightly which volume is greater here? 22.7 liters is greater than 22.4 liters. Why this volume is greater here, 22.7? Because this pressure is 1 bar pressure is slightly lesser. When pressure is lesser, volume will be greater. So the volume is always inversely proportional to what? Pressure we know. So if 1 atm pressure is taken, 1 atm means slightly more pressure. If pressure is more, volume should be less. That's why 22.4 liters. Now generally NTP condition. In NTP, the pressure is equal to what? 1 atm. And if you take STP condition, in this standard pressure means what? 1 bar. Standard pressure means 1 bar we take. Normal pressure means how much we take? 1 atm. So 1 atm means what will be gram molar volume? 22.4 liters. And 1 bar pressure, what will be gram molar volume? 22.7. Is that clear? So what is the gram molar volume generally? Volume of 1 mole gas. Volume of what? 1 mole gas. So volume of 1 mole gas at NTP. At NTP will be what? 22.4 liters. And volume of 1 mole gas. Volume of the same 1 mole gas at STP will be how much? 22.7 liters. This slight difference you have to understand. Is the difference understood? At STP, what is the gram molar volume? 22.7 for 1 mole of any gas. And at STP or NTP, at NTP, what will be gram molar volume for any gas? 22.4 liters. So this point mainly you have to understand. Okay. Now suppose example problem. A piece of copper weighs 0.635 grams. A piece of copper weight, how much is given? 0.635 grams. How many atoms of copper does it contain? Okay. Now check it here. Solution. Gram atomic mass of copper, how much? 63.5. 63.5 grams. And number of moles, generally formula what? Given weight by gram atomic weight. Given weight by gram atomic weight. So 0.635 divided by 63.5 will be 0.01 moles. So how many moles of copper here? 0.01 mole of copper is there. Now, number of copper atoms in 1 mole is equal to how much generally? Avogadro number. Avogadro number of atoms. These many atoms will be present in 1 mole generally, right? Now number of copper atoms in 0.01 moles how much? Then 0.01, here this one into Avogadro number, cross multiplication. So 0.01 into Avogadro number will be equal to what now? 6.02 into 0.01 means 10 power minus 2, right? It is equal to 10 power minus 2. So 10 power minus 2 into 10 power 23, how much? 10 power 20. So 6.02 into 10 power 21 atoms. So these many atoms of copper is present. In what? 0.635 grams of this. Next example 18. One more example. How many molecules of water and oxygen atoms are present in 0.9 grams of water? Now what is the given weight of water? 0.9 is what? Given weight. So given weight of water. And what is gram molecular weight of water? Gram molecular weight is equal to 18 grams per mole. 18 grams per mole is gram molecular weight and given weight is 0.9 grams. Is that clear up to this? Next. The next one here. Now gram molecular mass of water is equal to 18 grams. And number of moles formula what? Given mass by gram molecular mass. That is 0.05 mole. So these many moles of H2O there. 0.05. Now number of molecules. Number of molecules formula what? Number of moles into Avogadro number. Now in 1 mole, how many molecules will be present? We know 6 into 10 power 23 molecules. Then number of molecules in 0.05 moles will be number of moles into Avogadro number will be equal to number of molecules. Now here, if you take this one, what will be getting? 3 into 10 power 22 molecules of water. So these many molecules of water we get. Is that clear now? Next, as 1 molecule of water contains 1 oxygen atom. Okay, 1 molecule of water means what? H2O, right? In 1 molecule, how many oxygen atoms there? 1 atom is there. So in 1 molecule, 1 atom is there. Then these many molecules will contain how many atoms? The same number of atoms. So as 1 molecule of water contains 1 oxygen atom, so number of oxygen atoms in these many molecules of water will be equal to same. Because number of molecule, 1 molecule is equal to 1 atom. So 1 H2O molecule, 1 molecule of H2O is equal to what? 1 oxygen atom now. Therefore, these many molecules will be equal to what? The same number of molecules. So these many molecules equals to same number of oxygen. So these many oxygen atoms of oxygen. So these many oxygen atoms present in water. Is that clear? Next, one more example. Calculate the mass of a single atom of sulfur. Single atom of what? Sulfur. Yes. And a single molecule of carbon dioxide. CO2. Single molecule of carbon dioxide mass, single atom of sulfur mass. Yeah. Now first, gram atomic mass of sulfur, how much? 30 grams. Now mass of one sulfur atom is equal to gram atomic mass by Avogadro number. Gram atomic mass by Avogadro number. You know that 6.023 into 10 power 23 sulfur atom equals to how many grams? 32 grams. Right. Then, okay. Then one atom is equal to how much? Then one atom is equal to how much? There are. Is that clear?